Hello, dear friends. Thank you for joining us this week. I'm very excited to be with you today. And today, I wanted to talk about quite a few things. One of them being how do you actually perform data analysis? How do you find an interesting data set out there? How do you get access to it? How do you download it in your local computer? Um, how do you analyze it? How do you try to draw some conclusions based on the data and the analytics skills and really collection of tools that you have? And then how do you continue research if needed in the future. Um, Based on your setup, this could happen. This could take place in your own computer, in your own laptop, your own desktop. You could be relying probably on some kind of a cloud environment. Maybe you're using some kind of AWS infrastructure or Google Cloud provider or Amazon, Microsoft Azure. Really, the analysis part that will be showing here doesn't really matter. The tools I'll be using apply in all infrastructures. So an interesting analysis that we'll be performing today is something called investigating a data set of European soccer database. Some of you might be a big fan of soccer, some of you might be a big fan of other sports. In my case, I just picked this specific example, and I specifically wanted to look at a given country within the European soccer database. And as you can see here from my screen, I have links here where this is coming from. But basically, this is coming from Kaggle, which is basically a platform for data scientists that Google acquired a few months ago, if you remember. And this data set basically has leagues, countries, players, how many goals the team scored at home, how many goals the team scored away, things like that. So some example questions that I was interested in was how many goals has each team scored home, how many goals has each team scored away, and in total for each season. So as you know, soccer has multiple seasons. Within one season, which is usually September to May, within each season you have multiple events going on. You have, if it's based on some kind of a tournament, you have home and away goals. So this is something that I wanted to look at, and also I wanted to see how many goals has a team allowed home, away, and in total as well. And I also wanted to see another question here: how has a team improved over time? Basically, over time as seasons pass by, how many? What are some metrics that we can qualify a team has improved or deteriorated? And then a good question is there such a thing as a home advantage? You know, when you play a sport, you know that home is your advantage. That's I think a common perception in many sports. I really want to take a deeper dive and see if that's the case or not. Okay, so I hope I got you a little bit excited about this, and the next step is to take a deeper dive and see how did we do this. So really the first part that we do is importing some modules I'll be using. So far in your nano degree, you might already be familiar with NumPy and Pandas, which are basically our go-to, bread and butter for data analytics. And then in terms of visualizations, we use tools like Matplotlib or Seaborn, which allow us to really ornament our visualizations. In this case, the database that we'll be connecting to extract some information is based on SQLite 3. That's why I'm importing SQLite 3 here as well. Let me try and make this a little bit bigger so you can see my screen a little bit better. Okay, hopefully that's better. And then the next step would be bringing this database locally. So again, as I said, finding a data source online, finding an interesting data set that really sparks your interest, it's really important. So in this case, I was able to find this data set on Kaggle, and I was able to download it locally on my computer. So the first thing that I do here, I'm calling the SQLite 3 module, and I'm calling the connect method. And from the documentation of the database, I knew that this database is called database.sql3. .sqlite, excuse me. So if you're familiar with relational databases, you can do queries. You can do queries in non-relational NoSQL database as well. In this case, in SQLite, I'm doing a select statement of, so I usually like to start with the table names. In this case, this database has multiple table names, has country, table, a league table, a team table, and a match table. So from all these tables, I'm interested in a specific set of columns. I don't want all columns, I want a specific set of columns. So from all these tables, I'm extracting the country name as country, the league name as league, the season, the date, the match date that took place, the home, the team name if they played home, the team name if they played away, and then how many goals they scored home, how many goals the team scored away. And then really the key here to this analysis, this from and select part, is where we're able to join these tables, because that's what would really tie up our data together. So the way that we're doing that is after looking at documentation, in the table country, there's a column called ID, and that has to match the column country ID in the table league. And I have an AND statement here, as you can see. The same country ID has to match the match country ID as well. And so now that will basically glue my country in the middle with the league and the match. I also want to glue the league and the match together separately through their league ID columns. There's also the home team and home away tables that need to be matched as well. And in this case, I'm filtering here equals, so this equals here is a filter for the country Spain. And in many sports, in one country, you can have multiple leagues. In this case, I'm interested in this very specific Spain Liga, La Liga, which is also known in Spanish. Maybe a simple order by, and this is just for experimentation at the beginning. You can see how the data looks like. This is a comment in SQLite, so basically we'll be bringing all data sets, all the entire records. And then how do we bring it in? So we have this query now. We have the query object here. We have a connection object as well. Well, we use the Pandas read SQL method here. And Pandas is very versatile. You can read from CSV, if you've seen so far. You can read from a database. You can read SQL. You can read text. There's even modules for reading from PDFs. You can even read things from HTML from basic websites. You can even read things from APIs if your dataset is served as an API and so forth. So how do we run this query? Well, it's PD. Remember, this is a short name for pandas dot read SQL and then the query and connection as input. So that will give us our what is called a data frame, which is basically a well-formatted data structure within Pandas. It has columns, and each column has a data type. And by columns here, you will see that we have the country, the league, the season, the date. Basically, it should be a one-to-one mapping to the columns that we select in SQLite. So a date, a home, a team home name, a team away name, a home goal and away goal. And by object, that means that, as we'll see, most of them are coming in as characters, as strings, unless we explicitly format it in another way. So some observations. The first thing that before we start analyzing our data is to see if we have any missing values, if we have any empty cells, if we have any empty columns, if we have, if our data set is correct compared to another data set and so forth. So what I'm doing here, I wanted to make sure that all the teams within this data set are included. There are no extra teams, that's number one. And number two, there are no missing teams. So to do that, I used in Python. There's a method called set. Well, given a list of items, it will keep only the unique values within that list. So if I have a list of items 1, 2, 3, 3, and if I give that as input to set, it'll return me 1, 2, 3 as a set. So in this case, I'm looking at our data frame. I'm specifically interested in one season, in the earliest one, 2008-2009. I think this data set has data from 2006 all the way to 2008 all the way to 2016. So almost 8 years of data. So I'm looking at the team home column. I'm looking at unique values of that column. I'm creating a set that is called the dataset teams. Also separately, I went to Wikipedia in this case, and I looked for 2008-2009 La Liga teams. I was able to get to bring in those columns as well, and those teams as well. Notice when we work with datasets from other countries, you might get characters that are not in the Latin alphabet. So in this case, there are some accents here that you really need to know how to bring it in properly. So that's what I'm doing here. And then the set objects has a method called difference. In this case, I'm looking at the difference of the dataset that I have with the one that I downloaded from Wikipedia, and then I'm printing it out. In this case, you'll see that the set is empty. Great. So another thing that I want to look at is maybe missing cells. So in this case, I'm using I'm grouping all my observations by season. So that means that every record, as you'll see here, will be a season. And then I'm looking at the count method. Basically, it's an aggregation, what is called in Pandas and the relational database world. I'm looking at a count of how many records do I have for that season and that column combination. So for season 2008-2009, for country, I had 380 records. And you see that's the norm for every season and all of my columns. Great. Another thing that is useful when you do your data analysis is after some experimentation, you figure out that there's some analysis, some functions that you use extensively. So in that sense, or some modules that you use extensively, you probably analyze from a specific perspective or different view. You plot it, you visualize it, and basically that's what you do multiple times. So if you hear the word multiple times in programming, as you probably know by now, that usually means you have to create a method or a function. So in this case, what I've done is I've created a method called reset index and also pivot my plot series. So I made this a little bit generic. So it takes as input a plot type. The plot type could be a stack bar or a heat map, as we'll see soon. Stack bar means that for a given time frame, in this case, for a given selection in your x-axis, you have your observations stacked on top of each other. That's what a stack bar is, and we'll see it soon. A heat map is basically you have a matrix, and for each combination of x and y coordinates, you have a value, and that value is represented by a color, and usually the darker that color, the higher that value is. So that's the plot type. You can play also with the colors based on your preference and based on what are you trying to show here. And then another input that this method is expecting is how many goals were allowed. Input columns, values, title. I know this is a bit generic, and it's the first time we see it, but I have a small documentation here. Basically, covers the same arguments that I went over here. So this is my method. Before I explain exactly what it does, I wanted to give you an overview of basically based on the plot types and the different flags that we use. We create, in the end of the day, a chart, and we set a title, an X and a Y labels, and return that aggregated result. So in this case, the first example that I want to look at was home and away goals scored per season. Okay, so before I call our method, I wanted to see how does this look like. So I'm looking at our data frame. I'm looking at group by, where you can group by different columns. In this case, I'm grouping by season and team home, and I'm looking at the home goal. So basically, how many for each season and home. That's what this means, group by, as you'll see here in the output for each season and home team. How many goals they scored at home, and this is per season per home. Also, I wanted to see the same for away as well. In this case, I'm just printing the home goals. So in this case, for season 2008-2009, Atletico Club de Bilbao scored 28 goals at home. So if you look at the entire season, all the matches that this team had at home, they scored 28 goals. Obviously, the better teams, or the stronger teams, I should say, like Barcelona or Real Madrid, they obviously will score more. But before we go there, I just wanted to see how the data looks like. And this is now us calling here. So question number 1 that we're trying to answer here: how many goals has each team scored home on each season? So basically that. Before I dive into the method, let me take a look at the chart first that I envision of how it looked like. So I wanted a chart of teams on the x-axis. I wanted the y-axis to be home goals scored, and then I wanted to see some kind of time variation. I wanted to see how things are looking over time. So for example, remember we talked about Athletic Club de Bilbao, and here we're looking at the blue part of the chart, and there's a legend here that says season. So that's 2008-2009 season. So as colors, as you see them stacked up, that means that that's later in time. So Atletico Club here had this many goals. So overall had about 250 goals for the period of 2008-2016. And clearly you can see these long towers here, these tall towers, which is basically the high performing teams. Probably you're a big fan of some of those, in this case Barcelona and Real Madrid, and you can see over time that they're really sticking out compared to others. And maybe number 3 would be Atletico Madrid here. As you know, that's pretty consistent for the last few years in La Liga for these first 2 teams to be in the top 2, and Atletico Madrid is also to be in the top 3. So how do we create this chart? So this is us using the method that I explained earlier. We have a stack bar in this case. We have we're looking at how many home goals were scored, and then we're setting up some titles here: team home, as you'll see, season, home goal, score per season, and all that. And we're also plotting here the first 10 items from the return result. Okay, so we wanted to see how it looks like. So you can see here for each season, which is the columns. You have a team home, and then different teams. So this team scored 28 goals, 34, 32, and so forth. Some teams were not back there. Like, for example, this team was not there until, or we don't have any data for it till for home goals, basically, apart from 2008-2009. Another question that, or what is the conclusion here? So we have the 2 best performing teams, Barcelona and Real Madrid. Looking at the chart, it's not easy to notice any improvement or deterioration over time. So this is a clear limitation of this chart, and that's what we're exploring next here. So if we display the same information, but this time using a heat map, we can clearly see how each team has performed over time. So the challenge here, as you can see, is I can't really tell what is the size of this portion of pertaining to a season compared to other portions. So another way of visualizing this would be as a heat map. So we're calling the same method here, but this time the plot type would be a heat map. And this is the color option that I chose. It's basically yellow, green, and blue. And there's a legend here that basically with yellow you have the lower numbers, with green you have middle range numbers, and with blue you really have the high numbers. So on the x-axis you have your seasons sorted from 2008 all the way to 2015, 2016, and on the y-axis you have your different teams. So you can see, for example, that Atletico Club de Bilbao had 28 goals in 2008. They improved. They scored, this is home goal scored. They improved 34, then 32, then they went a little bit down. So you can see the variation basically, but another important thing that you can also see is the high-performing teams here, in this case Barcelona, Real Madrid. They're really sticking out here. You can see, for example, Barcelona and Real Madrid had one of their best years in this range that we're analyzing in 2011, 2012. Good. So that was the main difference of a stacked bar chart and the heat map. And you can do this maybe for a smaller set of teams that you're interested in. Maybe you can convert this to percentages. So you can see, for example, when you move from 61 to 57, you dropped a few points there in terms of percentage and so forth. But I think this this gives us a nice direction to move forward. So that was the home goals that we saw. As I mentioned, another way of looking at this, maybe compared to percentage, or maybe compared to raw numbers. So in this case, we're looking at a difference. So we're looking at the same data frame, but shifted by one period, meaning we're looking at the same data frame, but now how does it compare to itself, but shifted by one? So in this case, we're taking the difference of one team, one season compared to the previous season. So remember, the first season was 2008, 2009. We don't have a 2007, 2008 season. That's why this column here is empty. But basically, let's pick for example Atletico Club de Bilbao. In 2009, they scored 6 more goals compared to 2008. And if we scroll up here, we should see that that difference. So you see, we had 28 goals in 2008. We had 34 goals in 2009. That's a goal difference of 6. And the range here, the color I picked was completely different from the one that we saw before. I picked a cool, what is called color scheme. So basically, the more bluish the color is, the more negative, or the lower the number is, and the more reddish the color is, the higher the difference. So you see, for example, 2011, 2012, Barcelona had a really significant improvement. And if you're like a big soccer fan, then you definitely want to see what happened in 2011, 2012. You know, then you can take it to the next level of seeing maybe what transfers were made, what new players were introduced, maybe a new coach. But really, that's something you can do separately. Then similarly, I wanted to look at how many goals each team scored away. So I can do the same analysis now, but for away goal scores per season instead of home goal scores per season. Clearly, you can see the best 2 performing teams here: Barcelona, Real Madrid. Again, you can see that in the heat map as well, and as a differential map. Then maybe you want to look at total goals. You can do that. You can do that as well as differentials. So I wanted to switch things a little bit now and look at maybe goals allowed at home, away, and overall. So this was goals scored, right? Maybe you can look at goals allowed. See, the picture is completely different here. As a heat map is also more interesting and more diverse than the ones we saw before. And then maybe away goals allowed. So maybe a team played away, but how many goals did it allow? You can do that analysis as well. Another analysis that I wanted to do is how many goals has each team scored home against other teams overall season. So now this would be a heat map again, but now my X and Y axis will be teams. On the Y axis I have team home, as you can see here. On the X axis I have team away. And then each X and Y coordinate, or home and away coordinate, has a number attached to it. So for example, Villarreal here, and Atletico Club de Bilbao. Every time Villarreal played against Atletico Club, sorry, not every time, over 8 seasons, Villarreal scored 16 goals against Atletico Club when Villarreal was playing home. So, so this is basically home goals scored against other teams. So the home teams are on the left, the visiting teams are at the bottom on the x-axis, and you can see here that, for example, Barcelona and Real Madrid are clearly sticking out here. So that Barcelona, over 8 seasons, when they played home in Camp Nou against Atletico Club, they scored 25 goals. Another one is how many away goals teams scored. So you know that you definitely expect the team to score more goals when they're playing home, but this is the away goals. That's also another interesting view. Maybe you want to look at total goals. So in this case, there's no home and away, there's just team and team. So for example, when Barcelona played against Atletico Club, they scored 40 goals combined, home or away. And if I want to look at Atletico Club versus Barcelona, then Atletico Club is here. Barcelona should be, if you look at the bottom here, FC Barcelona is somewhere here. That's 13 goals. Okay. You can look at this from different perspectives. Just for the sake of time, I will scroll down a little bit more to see what other analysis we can do. Yes, another one is ignoring the goals, just looking at wins. So the previous charts we're looking at differences in just number of pure goals. So in La Liga, you get awarded points if you win, tie, or lose accordingly. So if you win, you get 3 points. If you tie a match, each team gets 1 point. If you lose a match, you don't get any points. So basically, you either get 3 points, 1 point, or 0 points. So if I'm looking at here, just number of wins now, ignoring goals or points, just number of wins. How many times Atletico Madrid won against Atletico Club de Bilbao over 8 seasons? That's 10 times. How many times did two teams tie against each other? So here, the redder the color, the more times a team tied against each other. So for example, Malaga tied 8 times compared to against Atletico Club, home or away, over 8 seasons. And the last question that we're looking at here is we'll be looking at how many goals on average does a team score home versus away, and the way to do that is basically we're looking at a ratio of how many goals teams scored home versus how many goals teams scored away. That's what I call here in this case the home advantage, and you can see that that number was the average was 1.4. So so on average, when a team plays home, basically it scores 1.4 more goals compared to playing away. So there is a home advantage after all. So yeah, then I think I'm concentrating a little bit here against those two rivals, Barcelona and Madrid, but I don't want to get people too opinionated on this. That's some analysis you can do on your own, regardless of which team you support. But yeah, these are some topics I wanted to cover with you. Super happy to take a deeper dive in our next week. How do we draw some more conclusions? What are some things we can improve on? How would you visualize this if you were looking at a data set and so forth? So until then, I wish you all the best and see you next week. Bye-bye.